Alright guys, we're back with part 4. So I did mess up on one part right here. You may have noticed it, you may not have. So on these parts right here, I'd actually typed in rotate, turn/rotate. And if you go to your Anim slot manager, you'll see we named it turn/rotation. So uh, let me see. So if you want to test this real quick, you can get your mannequin or your third person BP, get your blueprints and drag them out onto the scene, and then select them and type in possess right here and enable that, and then select the default mannequin for the ALS and disable it on him. And then when you play, you should get this. And that's what we want right now because we haven't set up the rotation. So we're not using root motion to rotate. We're using values that we calculate. And from my understanding, for the most part, you don't want to use root motion for basic movement like that because it can cause issues when you're trying to do stuff, because I don't think that the rotation is easily translated or inside the blueprints. So if you're not getting that, then come back here and check and make sure that this right here is named just like it is for your slot. And I believe we did that under the not moving. Yeah, so under the not moving, that's where we placed our slot. And that's where these animations will play. So, and that's also why we're using the play slot animation as dynamic montage, is because we want to be able to play these on slots. So I'm not sure if I had explained that to y'all before. So anyway, let's get started. With that out of the way, we need to come over here and we need to set up the rotation. So we're going to make a new function here in our third person character blueprint, and we're going to call this update grounded rotation. And then off of, we need to make one more function actually, and this will be a pure function, and we'll call it can update movement rotation. And so we're going to get our is moving value, and we're going to get our has movement input, and we are going to say that if is moving and has movement input. So if you don't remember, we can go back over here to the set essential values, and we'll say that is moving is when the speed is greater than 1. And our has movement input is when the average acceleration is greater than 0. So we're just saying, do we have speed and do we have acceleration? If so, well, we're going to do an or. So if that and that, or our speed is greater than 150, that means we're not walking. So I guess if we're moving or not walking, then let's see. Well, we need to do one more off of here. And this is just like to future proof it, but I'm going to go ahead and do this anyway, since even though it's not really necessary for what we're doing here. That way you'll kind of understand how they do it. So has any root motion, it should be under animation. And this is just saying that this is going to be true. It's going to return true. So we want to say not. So it'll return true if there's any animations playing that are root motion based. And from my understanding, where you want to use root motions at primarily is like if you're jumping up and grabbing a bar above you, or doing some kind of ninja tricks or something like that. Something that's not easily calculated, or something that isn't necessarily like regular movement. So let's see. So we are going to do return node here, and we are going to just plug in this value right here like so, and that will give us our can update movement rotation. So we're only using that to, let's see, so go back to your update grounded rotation function and drag this one out. And actually I forgot to change it to pure, so up here on the right, check pure. We want it to be a pure function. We're going to do a branch off of here. And I am going to connect it up like that. And so if this is false, if we can't update movement rotation, and this is primarily, I believe if I remember correctly, if this is true, then you're running, and if you're running or sprinting, then you want to control how the character rotates while they're running or sprinting, and so that's what would be going off of the true. But for this, we're doing false, because we want our false is going to be if you're not moving. So what we need to do is we need to add let's see, we need to do a branch first. So let's do a drag off here and do a branch. Alright, sorry about that. So let's see, where were we at? Okay, so we need to get the anim curve value. I don't think we ever saved that. So I guess we could, no, that needs to be off of begin play. So let's just do another graph, and we'll call this begin play graph, I guess. So we'll do event begin play, and you don't have to do this on a new graph. You could do it under event tick if you want, but I am going to drag off of this. Oh yeah, let's do a cast to AnimBP, third person AnimBP, and we're going to do mesh. Actually, we don't need to cast to it, my bad. Drag off your mesh and do a get anim instance. And we're just going to promote this to a variable. We're going to call it anim ref. And now we're going to create a new function. We're going to call it get anim curve value. And we need an input. It'll be a name, I believe. We will call this curve name, I guess. So we're going to drag off our anim ref, and we're going to get it, and we're going to right click on it and convert it to validated get. And I'm just doing this because this is how they do it, because in ALS, more than likely you're going to end up using this logic in multiple places, so it's best just to have it all going through a function like this. So if it's valid, we want to return and scroll down, add return node, and add an output to this, and we are going to make it a float, and we're going to name this curve value. And so off of this, we're going to get curve value, and it should be the one under animation. We're going to return that, and we're going to plug that into the curve name. And if it's not valid, we are just going to return nothing. So type in return and scroll down again, or duplicate this one, either or. And that should be it for that. So going back into the update grounded rotation, we are going to drag this out. And actually we need that to be a pure cast, so select pure right here. And I think it's supposed to be a pure cast. Anyway, it works either way. So this is going to be rotation amount, and make sure that you word it properly. Capital R, capital A. I think it's case sensitive. I'm not 100% sure. We're going to get the absolute value of that. So whether it's negative or positive, we're going to get the value. Now remember, I explained to you how the rotation amount curve works before, so I hope you remember how that works. Now off of this, we're going to say greater than, and we're going to say 0.001, just an arbitrarily small value, so that we know that it's not 0, but it's, you know, somewhere above 0. And that's what we're going to use here. Actually, I'm just going to do mine like this. You don't have to, but off of the true, we're going to add actor rotation. Yeah, so we need to add actor rotation. Add actor world rotation. So we're going to use this one again. We're going to multiply this. Oops. Multiply it by float. Float times float. And we are going to get world delta seconds. And we are just going to multiply this float by float. Actually, we can multiply this by an int. So int times float. And we will say 30. Now this is the same thing as they did. So on theirs, they divided the delta seconds by 1 divided by 30, which is the same thing as saying delta seconds multiplied by 30. So if you were to say, well, you know what, I'm not going to get into the proof stuff. That's the mathematical proofs. I'm not going to get into that, but anyway. So this is going to be our Z delta rotation. And let's see, we need to check and confirm that this works, so we need to hook it up first, obviously. So go to your tick graph, and we are going to drag this off of here, and we are going to connect it up right here. Actually, we didn't need that extra one, not for what we're doing. So we're just going to set essential values, update grounded rotation, and then catch values. So let's just try this out here. Yep, and there we go. Now it's working. If yours isn't doing this, then you did something wrong somewhere. Okay, so with that out of the way, we need to go to the third person anim blueprint and exit out of that. We can exit out of this. And I'll go back through all this in the end and explain everything in more depth here. But Yeah. So now we need to, let's see, update graph. So go to the event graph. And we need to add another function, and it's going to go right here after update aiming values. So go ahead and create a new function. We're going to call it update foot IK. And you can go back to your event graph and drag that out. We're just going to plug that in right here. Now, off of this, okay, before we do this, we need to create two more, or we need to create one more function. Set FootLocking. And let's see. So we're going to need six inputs for this. 1, 2, 3. These 3 actually are going to be name, and you can do 1 and then change it to name and then duplicate it, and the rest will be name. So this one will be enable foot IK curve. Kind of like that. The next one will be our foot lock curve. And then the next one will be our IK foot bone. This will be a float, a vector, and a rotator. So the first one will be, we'll call it current footlock alpha. The next one will be current footlock location. And then we'll have current footlock rotation. So these right here are going to be set inside of here, but we're also going to use it outside of here to plug in. Now we'll do that afterwards. So we'll go ahead and do the set foot locking logic here real quick. So we need a footlock curve value. So let's see, we need to see, okay, we need to get curve value off of this one. So the enable IK foot curve, we need to make sure that it's greater than 0. Because if it's greater than 0, then that means that the foot IK is currently enabled for this foot. So we'll do a branch off of that. And now, let's see, if this is true, we'll do a sequence. And then we will get, let's see, footlock curve. And we will get curve value off of that. And then we will promote this to a local variable. Yeah. We'll call it footlock curve value. And this will just save us from having to do this every time. And it'll save a little bit of processing too. That way it doesn't have to currently fetch it and over and over and over again. It'll be like it can just fetch it from a value variable. So now we need to set our footlock, our current footlock alpha. Yeah, we need to set our current footlock alpha. So let's do a set by ref variable. Oh, also, we need to have all these passed by reference. If you don't do that, this won't work. That's how you set by ref variable. So let's see, this one's going to be footlock curve value. So the one that we just made. We're going to see if this is greater than or equal to, let's say, 0.99. And that's just so that we know that it's the footlock curve value it's currently on. So it's currently active. And remember, we set those inside of our state machines. So if that's true, then we can set by ref. Yeah, we can set by ref variable. And so we need to set the current footlock alpha. And we are going to set it to be equal to the footlock curve value. So duplicate that and connect that right there. So let's create another pin. And we need to get the current footlock alpha. And we need to see if this one is greater than or equal to 0.99 as well. And we'll do a branch off of that. So if that footlock alpha is greater than or equal to 0.99, then we want to set our current footlock location and rotation. So let's say get current foot lock location and get current foot lock rotation. And after this video is done, I'll do one more where I just review all of it. I go back through and I'll explain all of it to you again, and possibly in more detail. So off of the true, off of here, set by ref, or just duplicate the one up here, and we will duplicate that because we need two of them. And so let's see, we'll do the current footlock location first, and then we will set the current footlock rotation. And we need to get our get owning component, and this is a skeletal mesh of our character, and we will get socket transform, and this needs to be actually in component space, not world space. So you have you have world space, actor space. That's kind of like local space to the actor. The component space is like component space to the skeletal mesh, and then parent bone space is like local to the parent of that bone. So we need to get the socket name, and that was IK foot bone. So let's get IK foot bone. And split this. Our location will be our new location, and our rotation will be our new rotation. So what we're doing here is we're just setting the current location at which we want to lock the foot, and lock the rotation of the foot, or lock the location and rotation of the foot. And we need to make sure that these values are on before we do that. So that's what we're doing here, and we need one more, and that'll be this will be the last one for this. So we can come down here and do a reroute node, and what we need to do here is another branch. And we're going to see if the current footlock alpha is greater than 0. I'm just going to line that up with those. So now we need to drag our well, we need to create another function. We're going to call this set foot lock offset. We're going to give it 2 inputs, a vector and a rotator. So this will be our local location and our local rotation. So we'll compile that, and we will drag this out right here. And that'll be off of the true. And we will duplicate these two, and those become our local location and rotation right there. So let's see, set footlock. Let's go ahead and actually, let's see, yeah. Actually, I thought, okay, yeah, we didn't do that. Okay, so we need to, let's see. So go to update foot IK and drag out the set foot locking out here. And we need to promote all 3 of these to variables, the alpha, location, and rotation. So right click on this and actually let's just drag out of here and promote to variable. Yeah, don't do it from inside there because those are referenced values, so it'll screw up the logic that we're working with here. And actually, I'm being an idiot. We need to do this actually for each one of our feet. Here, let's just call this left foot alpha, left foot location. Sorry, when I start doing these long videos like this, sometimes I can get zoned out. Left foot rotation. And we will duplicate these here. Right foot alpha, right foot location, and right foot rotation. Now we're going to use this to set our feet position inside of another node using a modify or a transform modify bone node. So let's just duplicate this here. We'll drag these out. Okay, anyway. So this needs to be, let's see. Well, this needs to be FootLock. No, I'm thinking the curve, it needs to be the enable foot IKL. So this is a curve called enable foot IKL, which is controlled on the animations, or yeah. So I'll go back over that later. So let's do I hope I spelt that right. If not, we'll have to come back and change it. And that's our IK foot bone. And we'll all right. So that looks right. Okay. So let's see. If we go into set foot lock offset, we can go ahead and finish this up. And this will be the last part of this one. So we need to do a sequence off of this. There's a few things we need to do, and I'll explain it to you later. It's a lot of logic going on here, so bear with me. Branch off of this one. We need to see if the character is moving on the ground, so grab out your character reference and drag off of him and say is moving on ground, and it'll add the character movement, the get character movement thing for you. And just plug that up into the branch. Now we need to set a rotation difference. This is going to be a local variable. So create a local variable, call it rotation difference. And we will make this a rotator. And we will set this right here. Go ahead and compile and save it. Just ignore this for now. We'll come back to that. So we need to get the angle between the actor's rotation and the last update rotation. And that last update rotation is going to be off the character movement. So drag off the character movement and say last update rotation. So this is going, we need to find out, the rotation difference will be the amount of rotation or the in degrees that the character has rotated since the last frame. That's what we're doing here. So we need to get actor rotation. And then we will get the delta rotator of that. And that'll be our rotation difference. So now we need to do something similar for the location, difference. So create a new variable and call it location difference. No, it needs to be a vector. Yeah. And we will set that right here. So I'll just drag that pin out there. And for that one, we need to get velocity. Okay, I think we got to get it off the character. So get the character reference and get velocity. We need to multiply that by the delta seconds. So get world delta seconds, it'll be a float. So it'll be vector multiplied by float. And we need to unrotate this so that it's oriented towards the rotation of the mesh. So drag off of this and unrotate vector, and this will rotate it. This will give us a velocity, the velocity since the last frame, but then we'll get that velocity and we'll orient it to where that velocity is facing the direction that the skeletal mesh is facing. So off of here we're going to get owning component, and we're going to get world rotation of that owning component. That owning component is our skeletal mesh, in case you were wondering. And then we'll plug that in there, and that's our location difference. And you can comment these if you want. I'm not going to, but like I said, this is the velocity, the amount of velocity since the last frame, in the direction from the player to the direction towards the direction that the character is facing. So you can think of vectors as arrows pointing in a direction, and the length of that arrow is determined by the values on X, Y, and Z. So yeah, and the same thing with the rotation difference, as I told you before. So we need to create another pin here. And this one we are going to be setting our local location. And also I forgot to do the same thing for this one. We need to pass these by ref. Okay, we already are. Just make sure that it's passed by reference is ticked on there. So we need to drag off of here and set by ref. And you can go ahead and duplicate that if you want. And in fact, I'm not going to hook that up right now, but I will reorient this here. So this is going to be our local location, and this one will be our local rotation. And remember, this is for our specific foot. so either for the left foot or for the right foot. So off of this one, we need to get our local location. So duplicate this, and we'll do basically the same thing for this one as well. We need to subtract vector minus vector here, and we need to get our location difference. So we need to subtract the amount of movement since the last frame from our local location. And what that's doing, to clear this up a bit, is basically every frame we're not actually locking per se in the as far as like keeping the leg from actually moving. So every frame the leg actually does move, but then we're just moving it back. That's all we're doing. That's what FootLocking is. So I hope that clears things up for you. I guess there isn't really a better way to do this. If anybody knows, you might want to let them know as well, because that's how they're doing it. And I don't know how else you would do it either. So we're going to rotate vector around axis. And we need this to be around the z-axis, but we need it to be inverted because of the angle in degrees that we're getting. So our angle in degrees is our rotation difference. So you can drag out your rotation difference here and plug that in. Oh, actually, let's see. We just need the z of it. My bad. So split it and drag out the z or the yaw. And that is our value. And what this is doing is it's doing exactly what it says. It's just rotating the vector around an axis. So we're getting the difference in rotation, and we're just rotating it back, but the opposite direction. That's why we used -1. If you used 1, it would rotate it in the same direction. So you would actually be getting more rotation every frame, twice as much rotation every frame, rather than removing the rotation or zeroing it out. And that's what we're doing, is we're just zeroing out that rotation. So it moves, it adds rotation, and then we're just removing that rotation. We're rotating it back around in the direction it came from. So with that out of the way, we're going to do a delta here, and we're taking the delta between the local rotation and the rotation difference. And it's basically the same thing as subtracting this rotator from this rotator. So if you say normalized A minus B, and then you can just plug that in there. And now that is pretty much it for this part. So give me just a second. I need to stretch a little bit, and then it'll only be a second. So I'm going to cut the video for a second. Alright, sorry about that. So I just needed to stretch for a little bit. I screwed this up apparently. So whenever I was doing that, so we need to redo all of these. Okay, so we have these set up, right? We fixed that. Should be able to compile it like that. Should be look fine. So we need to do a footlock. We need to do a another layer here. So we're going to call this one foot IK. We need to let's see, do transform modify bone, and we're going to unexpose the scale. We're going to set the rotation and rotation and translation to replace existing. And for this one, it's going to be IK foot L. Then we're going to duplicate this, and this is going to be IK foot R. And we need to add an input node here for this one. So this will go into here. And this will go into here. And then we are going to scroll down and drag out our left alpha, our left translation or location, and our left rotation. And then we're doing the same thing for the right. Oops. And let's connect this one up here. And then we will go to our anim graph, and we will do another linked anim layer, and we will choose foot IK. And let's see. Let's check it and make sure I didn't miss anything. I don't see any sliding. Okay, it does appear to be working. I'll have to look into this a little bit more to see how to make it look better. I think the reason why it's doing that right there is because of the settings that we had. Let's see if I come over here and I will kind of show you. And this dude's blowing up my stuff here, so let me put this on Do Not Disturb for a second. And let's go to mannequin animations, TurnInPlace, or I mean no, it's locomotion. So these values right here, I might need to adjust these values. That's probably what's going to need to be done here, is those values will probably need to be adjusted. But what we could do is, well, you know what? Let me do it. Let me do this in another video because I've already made this one extremely long, and I will get back to you all on that. So be looking for another video. Alright, well guys, so this is what I have so far, and you see that little snapping that goes on there. Well, I believe I know why it's doing that. So come to find out that the FootLocking system is kind of tied with the foot IK system, and that's the reason why we're getting that, and it's not looking like we would expect it to. So I may have to delay any further videos on this part so I can get back to this other project I just started, and I'll come back to this a little bit later to finish this series by adding the foot IK to it and cleaning the rest of it up. I apologize for that, but I do have other obligations as well. So I'm going to go ahead and show you one thing I did miss on this and some things that I changed. So I changed the value of the walk for the plant right foot to 0.5 and for the left foot to 0.95 because it seemed to work a little bit better. And you can play around with these values too by going to the game and going slow-mo and typing something like 0.3, and then you can test those values and you'll see how it kind of slides there. Anyway, I'll have to come back to that. It seems like there's a bit more to that system than I originally thought. So there's something else I missed as well, so let's go ahead and get that out of the way. And that's right here on the set FootLocking. We're actually supposed to check if it's greater than 0.9, greater than or equal to 0.99, or less than the current footlock alpha. And yeah, so anyway, I hope y'all enjoyed this series, and stay tuned because here in maybe a week or maybe a couple of days I'll come back to this when I have more time on my hands, and we'll finish up on this by doing the foot IK with it as well. So we'll see y'all in the next video.